So that's what f of x says that it's doing. F of x says take whatever is inside these parentheses, multiply it by itself 4 times. Now you don't necessarily want to multiply x cubed plus the square root of x times itself 4 times, because that would be a mess. That'd be a lot of algebraic simplification. But you could. But the point is, this is pretty complicated to raise to the 4th power. And what the chain rule does is it gives you a way to actually take the derivative without having to multiply it all out. Just like the product rule gave you the ability to take a binomial times a binomial, or any polynomial times any other polynomial, and take its derivative without having to multiply everything out. That's the point. Now here's another composite function. Your inside function, it's what's inside the radical. Your outside function is the radical itself. And take into account that g of x could also be written that way. I think it's time for Big Orange to retire. Could also be written this way with a 1/2 power. Because g of x's job is to take whatever's inside the radical or the parentheses to the 1/2 power. So that part has a change in it. Okay? Now this one is a combination of a product rule, because you have 2 functions, and the first function is 5x squared, which you can just use your straight up power rule to take its derivative. But your second factor has an inside and an outside function. And the outside function, once again, is those parentheses with that 4th power. And the inside function is what's inside the parentheses, which is going to be the x to the 3rd plus x. 5x squared is actually being multiplied by the function that's inside the parentheses and raised to the 4th power. But when we get ready to do this problem, we're going to have to take the derivative of this one and multiply it times that part of the function, and take the derivative of this one and multiply it times this part of the function. So this is 2 rules in one. You're going to find that's going to happen a lot through the rest of the chapter, is you're going to have to use more than one rule to actually take your derivatives. So you need to recognize when you have a product. So just remember that this is a product rule. And that the second part of the function then is chain rule. Because chain rule applies when you have composite functions. And we're actually going to come back and we're going to take the derivatives of all of these. Okay? So for the time being, let's just continue making sure you understand composite functions. If you have this problem where f of x is equal to 2x minus 1 and g of x is equal to 3x plus 5, just to be sure you understand how composite functions work, What this says is that if you want to take g of f of 4, the first thing you would do is find f of 4. And that's 7. And then that 7 becomes the input for g. So g of 7, or g of f of 4, is the square root of 26. Okay? And this follows kind of the order of operations, because you're going to do what's inside parentheses first, and then work with what's the next one out. Let's try another one. This is the same functions. That might be a duplicate. Let's see. Yeah, that's a duplicate. Sorry about that. Do y'all have a B? I think mine's back there. Oh, okay. Oh, no. I glanced too quickly. Sorry, I glanced too quickly. This is actually not the same one. This one says find g of 4. So g of 4 is equal to the square root of 3 times 4 plus 5. And since 3 times 4 is 12, then g of 4 is the square root of 17. And then that becomes the input for f. So that would be 2 times the square root of 17 minus 1. And that's 2 square root 17. We don't actually multiply that out, and we just subtract 1. So all you're doing is you're taking the inside-most part of the problem, evaluating that, and then plugging it into the next step out. You're going inside out. Let's see, and this one is same functions, but the first one it asks us for is g of negative 2. So the square root of 3 times negative 2 plus 5 is the square root. That's negative 6 plus 5, so it's square root of negative 1. And then that's going to become the input for the function f. Is this making sense to everybody? See the pattern? Okay. Now, here we don't have a number to plug in for x, so we're going to actually be plugging in the function. So the inside function is going to be 4x plus 1. And what f does is it takes whatever is in those parentheses, whatever its input is, and it squares it and multiplies it by 2. And then it multiplies it by 5. So in place of x, we put 4x plus 1. And if you have any problems in my math lab that asks you to do this, you can stop right there unless it tells you to completely simplify. Because this is just like the calculus part of it. I want to make sure you know what a composite function does, how it operates. I'm not interested in the 37 steps of algebra after that. Okay? You could square that, you could multiply it through by 2 and multiply that by 5 and collect like terms. That's all algebra. Your algebra skills get their work out other places. You don't necessarily have to do it here. Okay? And then we have g of f of x. And that means then that the inside function has just changed places. So then when we do g of f of x, that means we take the function g and plug in f of x as the input. And g's job is to take whatever that input is and multiply it by 4. And then add 1 to it. Okay? Okay, here's a little challenge for you before we go back and start doing derivatives. There's 2 functions being used here. H of x is the composition of 2 functions. What's the inside function for h of x? That's right, it's 4x plus 1. So that tells you that g of x is 4x plus 1. What's the rule f of x? What does it do? If this is functioning as your x, what's the rest of it doing? That's f of x. So what is f of x? It's whatever's on the outside. So basically we're saying that 4x plus 1 is the input for f. What does f do with that input? It multiplies it by 2. And it squares it. And then it adds 5 times whatever the input is. Okay? That is the outside function. That's exactly what it is. So this is your inside function. And f is your outside function. And these aren't really calculus concepts in and of themselves, but if you can't pick out the inside and the outside function, then you're not going to be able to do the chain rule right, because you have to know which one you're doing what with. So let's look at h of x. Remember that h of x, again, this time it's the square root of 1 minus x squared. What is your inside function? Exactly. Now, what is it inside of? A square root sign. So the function f takes the square root of whatever you put inside of it. So f of x is the square root function. Okay? That's the outside. Now the notation sometimes the book uses, just so that you don't get confused, this f of g of x, they will oftentimes write this, and I don't like it, but they do it. They write it that way. I hate that notation because it always makes me think I'm supposed to be multiplying something, and you're not. But if you see that notation, know that what this is telling you this is the inside function and that that's the outside function. So by the same token, if it's g of f of x, then they write that g-o-f of x, and you need to remember that the parentheses would go there. Okay? So don't let their strange notation throw you off. Now we're going to go through and learn how to do the chain rule. This one says, suppose f of x is x squared and g of x is 5x cubed plus 2. What is the derivative of 5x cubed plus 2 quantity squared? And you might think that it's just the chain rule problem because you know your chain rule problem says, well, you would just bring your power down in front and then keep what's inside and reduce your power by 1. And then you just multiply through by the 2. But that's not right. Because if you multiply out 5x squared plus 2, I'm sorry, 5x cubed plus 2, what you actually get is 25x to the 6th. 5 times 5 is 25, and x to the third times x to the third is x to the 6th, plus 10 x to the third, plus another 10 x to the third, plus 2 times 2 is 4. So that function is actually 25 x to the 6th plus 20 x third plus 4, and its derivative is it on page 18? I don't have the notes in front of me, but it's there.
It's not in the actual notes.
Okay. Don't worry about it being in the actual notes, because I'm going to verify something for you here, because you really just need to watch this so that you'll understand why you can't do what you think you can, what seems logical, okay? Because the real derivative looks like this. Sorry, that didn't belong there. So 6 times 25 is 150. X to the 5th plus 3 times 20 is 60. X squared. So there's the real derivative, and this is not going to be the same thing, because this comes out to be 10x cubed plus 4, which looks nothing like that. Okay? So that's why you can't just do the power rule. The power rule applies to x raised to a power, not to some other function raised to a power. The chain rule is kind of like a power rule, but there's 2 steps to it. So let's do a couple of simple ones and then go back and do some of the ones we just did. And this is just a reproduction of the formula. I think it's better if you see how we actually do it. Let's take this one to the top. I don't know when I paused that. I'll have a recording of doing this before. I'll post it, but then we'll have the rest of this one, because I do have one from last semester. So what this is, just to make sure that it's on the recording, this is the first factor times derivative of the second factor plus second factor, because remember, factors means things that are multiplied together. That's all it means. Times derivative of the first factor. Okay? So that's the process that we're going to take. So what we're going to do for the second part of this, before we try to go any further, is we need to take these 2 derivatives. Okay? So the derivative here is the derivative of x cubed plus the square root of x raised to the 4th power. And that derivative is 4, because you bring your power down in front, times what's inside the parentheses, reduce your power by 1, and then multiply by the derivative of what was inside the parentheses, which is 3x squared, because 3 comes down in front, times x rate, and then reduce your power by 1, plus, since that's the square root of x, that's 1/2, that's x to the 1/2, times x, and 1/2 minus 1 is negative 1/2. Okay? Now what was in the parentheses to begin with is still there. That help? So what was in there to start with is still here. It's the derivative of the second factor. It's the derivative of this. Okay? Now the derivative of 5x squared, everybody in here should be able to tell me in an instant what that is. 10x. Okay? So here's your final step. Let me get it where you can see everything before I start writing it down. Actually, you need to see that part right there. So my y prime, once I multiply everything out, well, I'm actually not going to simplify it by, I'm going to write it out as the multiplication, is I'm going to take my first factor, which was 5x squared, times all of that.
Would it be 10x? You said it was the same as-
No, that first factor is 5x squared. Okay, we're just
So
taking,
it's not the derivative.
it's not the derivative of it, okay? It's the first factor of it. Times the derivative of this. And the derivative of that is 4 times x cubed plus square root of x raised to the 3rd power times 3x squared plus 1/2 x to the negative 1/2 power, close your parentheses and stop. This is your first factor.
Why do you have both of those for the derivative? I'm just confused how you got both of those. Like, I understand how you got the second part of it, because you distributed, and those are derivatives of it, but once you put the 4 there, why did you put 2 separate groups of parentheses?
Because this is the derivative of this. And you have to multiply the derivative of the outside times the derivative of the inside. Okay? So you need the parentheses. So that was your first factor. And what all of this is the derivative of the second factor. So that's the first half of your product rule. And product rule says the next thing that you do then is that you add. So then the part that you add is your second factor. And we're going to multiply times 10x, that's right. Which is the derivative of your first factor. So there's your derivative. First factor of your function, 5x squared, times the derivative of your second factor, which was chain rule to get that derivative, which is why it's so long and ugly, plus the second factor times the derivative of the 5x squared, which is your first factor. So that's 2 rules all rounded into 1. And no, there is no simpler way to do it. I wish I could tell you there was, but there is no simpler way to do it. As close as you could come to a simpler way, you would have to actually multiply this quantity times itself 4 times. And then multiply the result by 5x squared to be able to use just power rule. And by the time you got done multiplying all of this out times itself 4 times, you have an expression that's still this long. And then you multiply it by 5x squared, and it's still this long. So it's not going to look any better than what that does. Don't worry about the derivative being messy looking. It's okay if it's messy. At this point, actually, if you can follow this example, you're doing well. If you're still a little shaky, that's okay too, because you're just going to have to practice. These take practice. Lots of practice. Let's see.
We do another example.
Oh, we're going to. I'm looking to see which ones we have that would work well, because I want to do the ones we've already done before I go to new ones. Okay, here's another good one. So here we've got f of g of x. This is the g of x because it's the inside. So this is what f of g of x looks like. Suppose we wanted to take the derivative of f of g of x. The derivative would look like this. Bring your 2 down in front, and 2 times 2 is 4. Keep what's in the parentheses. Drop your power by 1, so that's going to be to the first power. Then you take the derivative of what's in the parentheses. Which is pretty simple, it's just 4. Plus, this power is 1. 1 times 5 doesn't change 5, so we'll just keep the 5. Times the parentheses, but 1 minus 1 becomes 0. So regardless of the fact that 4x plus 1 has a derivative of 4, what does this become? That becomes 1. Anything to the 0 power is 1. Okay? So the simplification here, and I am going to simplify this one because I'm going to show you how we know it's right. Sometimes you can actually verify that it's right. To simplify this completely, we have 4 times 4x plus 1 times 4 plus 5 times 1 for that times 4. 4 times 4 is 16. 16 times 4x is 64x. 16 times 1 is 16. 5 times 1 times 4 is 20. So if I add 16 to 20, the derivative is 64x plus 36. Now I want you to look at that for a minute and make sure that you understand where all that came from.
So how come you take out the 4x plus 1?
Take out.
Well, you tossed it out.
Oh, this because it's raised to the 0 power. When you take 1 minus 1,
Oh,
it becomes 0 power, and anything to the 0 power becomes 1. Okay? It doesn't become 0, it becomes 1.
So when you factored it, you, for the first part, the 4x plus 1 times 4, you factor 4x plus 1 times 4 first, right? And you get 16x plus 4. The next line down. But one of them.
What I did was I took 4 times 4 was 16.
Okay. And then you.
Then I distributed the 16 over the 4x plus 1.
Okay.
Okay, and that's where this part of it came from. And then this is from here. Okay?
And where did the additional 4 come from?
Because it's the derivative of the inside of the function. That's the chain rule part. Okay? Any more questions? Anything you don't understand? Do I need to explain it over again? Was that a yes or a no?
I said yes.
Okay. So the problem that you got here is this is a composite function. G of x is the inside function. So you put g of x, which is 4x plus 1, in place of x in f of x, which is why f of g of x is 2 times g of x squared plus 5 times g of x. And you just have to recognize that that g of x is to the first power. So when you get ready to take your derivative, then your derivative says bring the 2 down in front and multiply it by whatever's in front. So 2 times 2 gave us 4. keep what's in the parentheses, which was g of x, and then reduce the power on the parentheses by 1. Then multiply by what's in the parentheses, because what's in the parentheses is itself a function. So you have to take the derivative of the inside function. Okay? And then plus 5 times, well, if you bring that 1 times 5, it's still 5. And if you keep what's in the parentheses, but you reduce the power by 1, that power becomes 0. And anything to the 0 power is equal to 1. But you still have to take the derivative of what was inside the parentheses. And that derivative is still 4.
Okay.
So there's where the last 4 came from.
That makes sense.
Okay? So then the rest of it, I just simplified it to give you an answer. And the reason I did that is because we can prove that this is the right derivative. It takes a little algebra. We can actually prove this one. Because if I take f of g of x, that function right there, four x plus 1 quantity squared is 16x squared plus 8x plus 1. And I'm going to multiply that by 2. And then 2 times 16 is 32, x squared. 2 times 8 is 16x. 2 times 1 is 2. Plus 5 times 4x is 20x. 5 times 1 is 5. 32x squared, 16x plus 20x is 36x, right? And 2 plus 5 is 7. Find me the derivative of that using your power rule. What is it? Plus. And that's exactly what we got with the chain rule. Why do you need the chain rule? Well, because we could actually simplify this, but simplifying that was not so easy. So you do need your chain rule. Okay?
Can we do
Let me find.
example 6?
Yep, here we go. Here's example 6. Okay. This is how I recommend that you do these. Okay? When you've got the function, tell me what the outside is.
Parentheses to
Okay. And don't put anything in the parentheses, just leave them alone. Okay? Because that's all it does. Whatever's in those parentheses stays in them. Tell me what the inside function is. Okay, does everybody agree so far? Okay. Take the derivative of both of those.
parentheses to 7.
Okay. And that's exactly what I want you to write. I don't want you to put anything else in those parentheses. Just leave them alone for now. Okay, we can plug in later. Take the derivative of your inside. So the derivative of the original function is equal to this times this. And now that we're at the last step, now that we're about finished, now go back and put in what your inside function was. So here's your process. Find the outside, find the inside. Find the derivative of both of them. Okay? And then multiply the two of them together. That's really what you're doing. Katie, you're frowning.
I can't see, I was just thinking.
Oh, okay.
Is that the end of that or is there more?
That's the end. I mean, you could,
Well, see, I'm a little confused because it said the dx times that, and then you said dx equals that.
that's the derivative of that. It's not dx times that. It's saying take the derivative of this stuff. Okay?
So,
I don't really like that notation at all.
so it really just gets long and complicated when you have to mix the product rule with the chain rule.
Yes.
And that's where you have it, where it's like first factor times second derivative.
Mhm.
And then it's plus the
Right. Okay, let's see. I think we're,
So.
remember the chain rule's two-step process, okay? That's on your notes.
We're supposed to have an exam on that on Thursday when we come
No,
back.
I just moved it. It's gonna be Tuesday after we come back. Okay? And for practice, when we come back, I will go ahead and do these for you so you can look at them and post them. So be sure that you look for a recording, and I'll get those done for you this evening and get those posted. Y'all have a great fall break. Enjoy yourselves, and don't worry about calculus.